If you eat it,
All right, good morning, e-learners.
I feel
No, I don't want to know.
Just waiting for the bell to begin so we can get going. Anybody absent today? Madison.
I was too busy wanting.
I didn't even see it. Can we do 7 and 8?
We can.
Yeah, I didn't even bother trying.
Oh my word. Didn't even bother trying?
I
I
was
didn't
tired,
even
okay?
do it. Okay. I didn't know what to put.
I
Because
literally,
for
I
seven-
literally wrote in pen.
7, the first one is not. It's not the given. I didn't know what to do.
I literally did my homework.
Still hasn't run, right? All right, here we go. So, I didn't hear anyone that said, I didn't get questions number 1, 2, or 3. Is that true?
That's light work.
Yeah, I had a bunch of people said, 7 and 8, kick my butt. Okay, so let me just paint the picture of what it's going to be like for some of you for a solid year. I mean, for a solid 2 weeks, maybe even a month. You're going to struggle at doing proofs, right? You're going to struggle. Now, I'll define struggle. Struggle means that most of the time you're going to say, I don't know what to do next. That's a different struggle than, I don't even know what's going on. So our goal this week is to get past the, I don't know what's going on. Right now, you could be in that position. I don't know what's going on. But what we can't have by the end of the week is, I don't know what's going on. The I don't know what to do next is going to be a constant theme throughout the year for everyone at some point, and for many of you all the time. That's why students always say typically that geometry is one of the hardest math classes, because it requires logical thinking. And it requires you to play a chess game in your head and to know what is the next move. And those are things that are really challenging to teach, right? I will show you what the next step is, and you will say, okay, I understand the step. That's the other part that you need to make sure this week, is that when I do each step, you're like, okay, all right, now that I see the step, it makes sense to me. Most students don't struggle at that at all. Like when I show the step, I'm like, okay, I see that, but how did you know to write that? That's the kind of part that's the challenge to teach. So for questions 1 through 3, we just solve an algebra problem, which you guys already know. All you had to do is cite for reasons was all those properties. So did anybody struggle with 1, 2, or 3? Which one?
I want to say 2.
Okay, well let's do 1 first. Where are we at? Okay, here we go. So number 1, well, let's see. The first step is the given. Second step, what did you do to both sides? Well, it looks like we added 5 to both sides, so that's the addition property of equality. And the last thing we did, we divided both sides by 4, so that's division property. So now we're on number 2. The first step is always it's the given. So now let's see what they did. I'm just looking at, let's see, they went from 3a over 2 to 3a. So clearly, how did they get rid of that 2? They had to multiply both sides by 2, and you can see they did because 6 times 2 is 12. So that's the multiplication property. Last step, now it says, well, there's no 3 attached to the a. So they must have,
Right.
you got it, 100%. Division problem. Questions on that? Yeah. So it would be given, multiplication, division. Those are your three answers. Given, multiplication, division. And that's the properties. And all we're doing is stating the reason or the justification that allowed them to do each step. Number 3 follows pretty much the same pattern. The first step is the given. The second step, they're multiplying both sides by 3. So that's the multiplication problem. A multiplication property, sorry. The last step, it looks like they're subtracting 7 from both sides. Subtraction property. Okay? We will have 3 more of these tonight. You should be able to do questions 4, 5, and 6. No issues, right? This is kind of like giving you a boost up to proofs. Like, okay, I can see where that step comes from. You will also have 2 more proofs tonight of the uglier kind of geometry proofs. All right. So the question is 7s and 8s, 7 and 8, 7 and 8. So let's take a look at 7 and 8. So I'm going to do it on this board over here. So you're given this big honking thing that looks like this. Now, I'm going to leave off the arrows. I'm being efficient. No, I'm being lazy. And you're labeled this as 1, 2. Did I leave one off? I did. 3, 4. No, there isn't a 4. Sorry. It is 1, 2, 3. Okay. And then you're further told it's A, B, C, D. So you got a point here. So it's A, then B, then C, then D. And the vertex is O. All right. So the first statement, which completely throws me under the bus because they didn't write the given as the first statement, as Katie clearly saw. She's like, well, that's not the given. And you're right. I'll just say, we're going to get in the habit of always making the given our first statement. Even if the book doesn't, always make your first statement the given. There's a few times where maybe it doesn't make sense, but almost always, I mean, I can only think of maybe 3 proofs in the entire book where they don't use the given as the first one. All right, so let's see what the statement says. It says the measure of AOD, so a little m, the measure of angle AOD. Sometimes it helps to do it lightly with your pencil to see what they're talking about. So I've got A, O to D. So they're talking what? One of the smaller angles or the whole honking thing? The whole honking thing, right? Immediately, as soon as you see the whole thing, what postulate should you be thinking about? Angle addition postulate. Immediately. That's the one we got.
Sorry, do you need
I have no lunch money. Very good for those who said angle addition postulate. Okay. The further of the statement, it says the measure of angle AOD is equal to the measure of angle AOC. Is that right? AOC plus the measure of angle 3. AOC plus the measure of angle 3. Okay. The whole honking thing is equal to this angle right here plus angle 3.
Angle addition postulate.
Yes? Cadence?
Yeah.
All right. Do you see that now? All right. So you don't beat yourself up by saying, okay, why didn't I come up with that? Right? It's you're building. You're like, okay, now I've kind of seen what proofs kind of go. Right? Every day, trust me, it will get maybe a tiny bit easier. Right now, it will be hard. Okay, so there's your statement 1, angle addition postulate. The next statement is the measure of angle AOC. The measure of angle AOC is equal to 1 plus 2. So the measure of angle 1 plus the measure of angle 2. So now we're going to look at just this angle right here, and it says it's 1 plus 2. You tell me, what is that? What allows me to say that the big angle is equal to these two added together? Reflexive property would mean that you equal yourself. If I had said the measure of angle AOC equals the measure of angle AOC, then that's reflexive. So look at me. This angle is equal to 1 plus 2. If I want to call this the big angle, well, it's got to equal to the sum of its parts. It's the angle addition postulate again. It's the same thing. It's no different. Whenever you look at me, whenever you get this is equal to whatever the angle is in between, added together, that's the angle addition postulate. So the first two ones are angle addition postulate. So I have these two statements right here. Let me make my D a little bit nicer here. Here's the where geometry becomes ugly, because right now you don't have the lot. Maybe some of you do. Watch the magic. You ready? Red pen. What did I just underline, Karis?
Oh my goodness.
What did I just underline? Did I underline something different or something the same? I can't hear you. The same. Reflexive property says anything's equal to itself, right?
Yep.
What's the substitution property say?
Right, you can solve any of those things.
So if I see an AOC, what could I write?
And
Oh my God.
That right there. If I see AOC, I can write that right there. So that's what I'm going to do. I see an AOC right here. I'm going to write this. So I'm going to rewrite this. The measure of angle AOD is equal to, I'm not going to write AOC. I'm going to write this because that's what it equals to. The measure of angle 1 plus the measure of angle 2. What's left, that part, plus the measure of angle 3. And that's what it asks us to do. And that's the what, last step? Right there. What property did I just use when I used the substitution property? This was probably one of the first proofs I ever saw as well, too, and I was equally as lost as you are. But what I wasn't, which is what hopefully some of you are, you're like, okay, I see the logic now that you did the whole thing for me. And trust me when I say you will be able to do this. And this is absolutely an easy one, but it certainly isn't easy right now. And you should all be like, I'm going to fail geometry right now. I know it, right? Trust me when I say you're no different than any other student. It's not a challenge because it's easily done in geometry. All right, that is number 7. That is number 7. Yes?
Yes.
Now that you see it, right? You're like, well, maybe not all of you, but now that you see, you're like, oh yeah, I can see that. But how was I supposed to know to do that? That's the logic. You're going to see me do this many times, substitution. You're going to get comfortable, like, I don't know how to do it. Maybe a substitution will work here. And so there's like some scratch work. Well, what would happen if I substituted? There's other times where you guys know those mazes, those big round or rectangular mazes, and you got to start and finish. And you're like, well, I don't know what to do. Maybe I'll go in this direction. Oh, that's the wrong direction. That's kind of like proofs are. Also, what's the other technique to solve those maze things?
Just draw a line straight to it.
No.
That's what I do.
I mean, some people start, yes. Some people start at the end and they kind of meet in the middle. That's another way of doing a proof too is, hey, this is where I got to end. I know it has to say this. How am I going to get a 1, 2, and a 3 to appear? Well, the only way you're going to do a 1, 2, and 3 is an angle addition postulate of some sort. This particular one is only 3 steps. So, but the ones that are longer, the ones that take up a whole page, we'll get to those by next chapter. Sometimes you may want to work from backwards a few steps and then start. You'll see me do that technique. All right. That was 7. Let's look at 8.
Okay.
Yeah. Number 2 was angle addition postulate. So what allowed me to say this, that AOC is made up of this angle plus this angle because any angle is made up of its parts. All right.
I think at the first part of it.
Did anybody think they'd have the answer to number 8?
I would like to say so.
All right. So 8 starts like this. It's a segment. I'll just say this is, it's kind of similar to the previous one. You got F-L-A-T, flat. F, what's a T? L, A,
They actually did that.
T. Yeah, sometimes.
I just got it.
Further, it says that, this piece, Liam, what do the red tick marks mean?
Congruency.
It means they're the same. That means the measurement of this piece is exactly the same as the measurement of that piece. So this time I'm going to write the given and I'm going to write where we're going. Oh, by the way, notice on number 8, the very last statement is blank. What has to be the last statement? Always in any proof. Right, what you're trying to prove. So that one's kind of a gimme, right?
Gimme.
The first one, well, we've seen the previous one, they didn't write the given, but this one does say given, so you already know the first and last statement. So I'm not going to cover those. You should have gotten both of those. So the first statement, which is the given, which is the tick marks, right? And it says that FL, notice no line over the top, we're talking about distance, is equal to AT. There's your first, and 2-column proof. Right? I wrote that there.
Yeah.
All right.
There you go.
There we go. Given, G for given. Right?
Oh, it's like, wait, I didn't have to write it out.
You're going to see me do a lot of abbreviations. The next one is Wes's. It says that LA is equal to LA. Wes, what's the reason? That's reflexive. So here's what it's saying. And remember I said we're going to use reflexive a lot, right? And I said it doesn't make much sense until we see it in the proof. It says that this is equal to this. Why do we make this statement? Because where we're going, last step, FA is equal to LT. I need to get an inequality. The only way you get an equality is to start with an inequality, like I did right there. But I need to be able to say something more. So I like this, that LA is equal to LA. All right, that's reflexive, REFL. REFL, reflexive. Don't use an abbreviation if you don't know what it means. Right?
Yeah.
The next statement. If we have two equalities by algebra, guess what we can do with them? Let's add them together. And that's where you see it adds that to that. What's FL plus LA?
FL plus LA.
I don't know. It's FL plus LA because it has no distances up there. Like there's no numbers. So FL plus LA is equal to AT plus LA. Okay?
Yeah.
And that is going to be the, what did I just do? Chandler? What allowed me to turn these two into that? What literally did I just do? How did I turn FL and LA to FL plus LA? What did I literally just do? Well, just addition, so addition property. I was going to give you. All right, so addition property, ADD property. Okay. We good?
Yeah.
Is anybody lost on the? Okay, I don't know why you did it, but I understand, the reason. That's where you need to be. I understand the reason, not why I'm doing it. All right, that comes later. All right, does this look like this now?
No.
Well, I don't have an FA and I don't have an LT. That's a problem. Now, they show you what to do next, but I'm saying from a logical sense, if I don't have an FA, I need an FA. Let's look up here. What's FA? FA goes from here to here.
Okay.
Somebody help me.
FA is FL plus LA. Where's that?
Voila. So that's why they have the next two steps, right? And they wrote two statements. It's still the same thing. All they're doing is they're going to name this segment and that segment. So I don't know if this is the way the book write it. This is the way I'm going to write it. So FL plus LA equals FA. Maybe they wrote it the opposite way. I don't know.
No, that's how they wrote it.
And then LA plus AT equals LT.
Yeah.
So LA plus AT.
Don't forget your semicolon. I'll mark you off if you don't.
Well, I'm gonna put one underneath one, so I'm not gonna put a semicolon. If you write them next to each other, I need a semicolon. Equals LT. And what allows me to say that the big segment is made up of the two added together? What allows me to say that?
I know the answer.
I know, absolutely he does. For the rest of you,
Oh.
what allows me to say the big segment is equal to the two smallers added together? Help me out. Segment addition postulate. The previous one, the big angle is equal to the two inside ones added together. Angle addition postulate. Segment addition postulate is it's not its twin, but it's bestie, right? It's the same basic idea. Correct. So this is called the add post.
No, it's not.
How's that for?
Line segment angle.
Thank you. +1%.
Thank you.
Why did I say that? Sound like a fool now. Okay, so the seg and post. Thank you, Seth.
You're welcome.
Keep me straight.
Oh, that looks awful.
It does. We okay?
No.
Now you know why I do
I'm not
PowerPoint.
Fix it, please.
You're
Well, I'm erasing with my hand. It doesn't erase very well.
It's making it even worse.
All right.
you
Okay.
Ignore that. You don't look at
Hey, we're down to the last step. Like there's nothing in between this and this. So the question is, how does this turn into this?
it.
It already says it.
Yeah.
Yeah, I know it does, but what I now got to give a reason. What allowed me to turn this into this?
Here's what we get.
Okay, so red. Once again, this is an easy one. It certainly isn't easy right now, but this is one of those more easier ones. Okay, so let's see what we got. We got an FA, we got an LT. Well, I got an FA and an LT right there, but they're equal to different things. FA is equal to FL plus LA. Wait a minute, what's this one say right here?
They're equal.
That this piece and that piece, Paris, finish it, the two that I underlined from where I put the check mark. The two that I underlined, according to this check mark, means what? The relationship between these two. You see the two that I just underlined? What's it say right here? What's it say right there? So the two that I underlined are, therefore this one and this one must be equal. So all I'm really doing is I'm taking this, and since they're equal, I'm substituting that in for that. Like, well, how can I do that? What allows me? Because it literally says right here, if you see an FL plus LA, you can write AT plus LA, right? Well, I see an FL plus LA, so therefore I could write AT plus LA. Well, that's what this says. Therefore, these two are equal. That's a harder substitution when it's substitution. So your last step is substitution. On fire, right? I'm going to fail geometry. Sure. Yeah, if I gave you the test right now, you all would fail, probably. Right? That's not where we're at. We're going to work through the proofs every day, and it's going to be tough, and it's going to be hard. And if you sit there and you choose to pay no attention, yeah, you're going to fail, absolutely. Like, no joke. But if you pay attention, I'm telling you as a teacher, like, you'll be okay. Maybe you don't get an A or a B, but you will at least pass the class. By the way, proofs are the difference between an A or a B. You can get a C in my class if you can't do any proofs. And right now, all of you are probably thinking, well, I'm getting a C this year, right? Oh, trust me when I say it's a process. You got to trust the teacher that it's a process.
I think C.
I was in your place, 30 years ago or 40 years ago, and I just remembered, I told you this last class, which was, it was 2 weeks before I could do a proof by myself. And I'm the math teacher, and I was always pretty good at math. But it was 2 weeks before I literally okay, now I kind of get it. And once you get it, trust me, it's a pretty good feeling. So my goal for all of you is to get you to where you're not struggling with the reasons. You're struggling with what's the next step? How in the world am I supposed to know this stuff? Yeah, that's the hard part. All right, let's do class. At some point, Seth is going to come around and grab the homework.
Can that be now?
Now we did not do one of the proofs in class. We left up on the second one. So we're going to start up. We're going to do 3 proofs in class today. We're going to do 3 proofs in class. And then homework will be the same thing as it was. You'll have about 6 total proofs, maybe 5 total proofs. Yeah, it's just the next ones. But I'm gonna have you do the 3 algebraic proofs so you can build some more confidence that you know how to actually physically write a proof. Then we'll do the geometry proofs as well, which are the more challenging ones. All right, what's the next thing coming up? Quiz on Wednesday. We'll talk about tomorrow. Hey, we got a 3-day weekend. I don't know about you, but I need a 3-day weekend.
Yes.
Our algebra review 2 does not happen during the chapter. It's going to happen after the chapter test. Oh, that? Well, I can't help the calendar. That calendar is what it is. All right, here's your homework. So once again, these are the algebra proofs and 2 geometry proofs. For me, even as a student, sometimes I would struggle with these fill-in-the-blank proofs. So by the end of the week, we're going to get a proof that it's just blank. There's nothing to fill in. I should say, they give you nothing other than the given and the proof. But for the first, chapter or so, they will give you these what are called fill-in-the-proof proofs, where you're either stating the reason or the statement itself. And a lot of times, because they're forcing the logic upon you, some people run into issues because they're like, that's not how I would do the proof. If you get to that point where you're correcting, like I would do the proof, there's an easier way of doing it, good for you. But
For last night's homework, I actually only did 9 through 10.
then you're already done, then aren't you? You just got to do and those are the easy ones,
Those are
right?
the easy ones. I'm going to do that right now.
Okay.
If you don't mind.
All right, so same class. I'm going to roll through these. Nothing has changed, Matt.
I actually sleepy this morning. So.
Okay.
You're telling me.
All right, you guys ready now? So I'm gonna run through the starting slides. You've already copied this down. It should all be in your book of. Everybody was here on Friday, yes? There's nobody absent. Okay. So same slides from last class. So we talked about the properties of algebra. These were those properties: the addition, the subtraction, the multiplication, the division, right? Properties. You already know these things, except they're called properties now. And they are justifications throughout the year. I will say, after this chapter, we will use these, I wouldn't say infrequently, but certainly not frequently. Whenever you add, you just simply say, hey, I'm doing the addition property. Whenever you're solving an algebra thing in a proof, and you will, right, you're going to use these properties right here. Okay? Then we have these 3, the reflexive, the symmetric, and the transitive. The reflexive, we just used in that previous proof. All right? And we will use a reflexive property often. The symmetric property of A equals B and then B equals A, rarely used. The transitive property, if A equals B and B equals C, then these 2 are equal. We use that a lot. Right? It's the classic, but it's got to be in that syntax or that context. If A equals B and B equals C, then these 2 are equal. The one that we use more often, as you saw almost every proof we did so far, is substitution. Substitution says if A equals B, then anytime I see an A, I can write B. Or anytime I see a B, I can write A. That's used very, there's probably every single proof we do has a substitution property. Almost every one. And the ones in yellow also work with congruence. So there's a reflexive property of congruence. When we get to triangles, we'll say that this triangle is congruent to this triangle. So we will have that congruence property for both reflexive, symmetric, and transitive. If this triangle is the same as this triangle, and this triangle is the same as this triangle, then these 2 triangles are congruent as well too. Lastly, we had the distributive property. Distributive property, I want to say there's probably 5 or 10 proofs that we'll do the distributive property, but not too many times this year. So proof is a logical way of showing that a conjecture is true. Every single theorem or corollary that I give you this year, we will prove with a few exceptions. So in my honors class, I prove everything. There will be times when I say, I'm going to write this down. Do you guys want to prove it? Right? And it's not a game where I'm saying wink, wink, yeah, I can prove it. No, I mean, I can prove it, but there are times when the amount of effort it takes to prove eats up the solid, 15 minutes of class. So there'll be times when I say, read the proof on your own, it's in the book, or I'll say, if you'd like to, and it bothers you, because this is supposed to be a class on truth, if it really bothers you, I will take the 15 minutes and prove it for you. But if not, we're going to move on. That won't happen for a while. The first method, and there are a bunch of methods we'll use this year. We've seen 2 so far. One's called an informal proof, and one's called a formal proof. And about formal proof, the first type we learn is what's called a 2-column proof. Statements on the left, reasons on the right. It starts with the given and it ends with the prove. So your given is your starting point. Your any point, how you know you're done is prove. And all the statements have to follow a logical sequence. We don't put them in a random order. It's like playing a game of chess or checkers. Checkers better, Micah?
Yes.
Okay. So in checkers, you don't start with the final move. Oh, you don't have any pieces left, right? You start with the first move. You move one piece out. You don't even know if you're going in the right direction sometimes in checkers, right?
My dad starts with the final piece. He takes on the pieces and like three.
So he plays the.
Yeah.
All right. So we started off by showing you this quick, and this was, by the way, did anybody notice this actually was the homework question
Yeah, I
number?
did.
Yes, I did.
Okay, thank you. It'd be a bad year if no one noticed that. Okay, so you're gonna have 3 of these tonight for homework as well too. So this is just to get you used to this format. But we start with the given. That's your first statement, right? We end when we have the proof. Now I put this smack dab here. Where should I put it? Like way at the bottom. This is kind of a bad habit. I mean, I already knew how far it was going. It was only basically 2 steps. But if you absolutely put your proof thing right smack here, and you think that you'll have enough space, then you wind up not having enough space. Sometimes though, it's good to write that statement there so that you can visually see when you're done. Like, how do I know I'm done? You kind of forget that, especially when you're doing a full page for a proof. So. Let's see, to solve this, I would add 5 to both sides. That would give me 4x is equal to 3. That's using the addition property. To get rid of 4, I divide both sides by 4. That's the division property, and done. So that's an algebra proof. This is used absolutely 100% inside of geometry proofs, but they just give you an algebra 1 at start just so you can get comfortable with this 2-column proof, who's lost. Okay. You end your proof with either QED, with periods right here, quadratum demonstrandum. That means that which was to be shown in Latin, or you put a little square, right? A little square. Yeah.
There should be a dot after the D because
There should be a dot after the D. Thank you. On fire today. All right. We did this one in class, and that's kind of where we finished. We talked in the belt. We didn't get to do the second example. So let's do example on box number 3. So let's do the one in box number 3. This one right here. Now, since you've already done homework, this one has a similar flavor to the ones we did in homework. So I would hope that some of you can actually take a solid guess at what the next step should be. All right, Bailey, what's always the first step? A given, right? Now, you guys are going to make a liar out of me because halfway through the year, like, Mr. C, you didn't put the whole given. So you have lots of leeway. Like when the given is long, like it's maybe 2 sentences long, sometimes you may want to start with just using the first phrase of the sentence, and you'll throw the second one in later. We're not there yet. We're just going to throw that whole given as our first statement. And the justification, as always, for the given, the given. I mean, we are given that, right? We are asked to prove something based upon a given. So this is the hypothesis of an if-then statement. If this is true, then this, right? Chris, how do we end a proof? How does the proof end? How do I know I'm done? How do we don't write the word proof. How do we end a proof? Okay. You end a proof when the very last statement I make is this one right here. Some students, myself included, write that at the very end, just so that they can see where am I going. Plus, it gives you some hints at where you need to go. Now, I can't put a reason here because I don't know what the reason that's true. That's what we got to figure out now. All right, so here we go. I got to show that this angle right here is the same as this one. You see the little red arcs on your paper? They're black for yours, right? You see the arcs, everybody? Are you with me? It says that this arc is the same as this arc. Remember, arcs in geometry mean congruence. That means they're the same. That's what this statement says right here. That AOC, which is right here, is the same as that one. Okay? Notice both angles share angle 2. Can you visually see that? Okay. I need to get something clearly that says something about 1, 2, and 3, right? Because this doesn't say anything about 1, 2, or 3. I'm kind of giving you a hint of where we need to go. Hint of where to go. Connor, if you just look at angle AOC, what can you tell me? And I don't mean cubed, obtuse. Based upon the diagram, what can you tell me about angle AOC? Visually, when your eyeball looks at AOC, what do you also see? Sometimes it helps to draw AOC. There's AOC. Visually, what can you tell me? And I don't mean a cube. It looks a cube. I can see that AOC is made up of angles 1 and 2. That's good, because what does it say down here? It says I need to somehow get angle 1 involved, and I just got angle 1 involved. So what's the statement you want me to write? Is equal to. We're just going to write that exactly what he said, but we're going to write it in the formal way. So we can say the measure of angle C is equal to angle 1, measure of angle 1, plus the measure of angle 2. Are you with me? Geometry's hard too because the concentration level has to stay strong when you're doing a proof. All right, Danny. Taking what Connor just said about AOC, what can you tell me about BOD? And I'll draw that move. So here's BOD. Visually, what can you tell me? Yes, it's probably a cube, but don't worry about that. What? C is a middle ray. Does that help us get to this? Doesn't say anything about rays, but if it did, you're on it. I'm looking at just this. Visually, what do you notice? Okay. Visually, what do you notice? Do you notice there's a 2 and a 3 right here? Okay, it's on your paper. Do you see that between BOD, there's the number 2 and 3?
Yes.
When I ask for visually, that's what I'm asking for, right? You could also see that, well, it's got part of an arc and part of an arc, or a full arc right here, that sort of thing. So he said that this angle is made up of 1 plus 2. What can you tell me about your angle? We're going to write that. Both of those statements, Connor and Danny's statement, right there. Separated by who was my semicolon boy? Oh, Seth. There you go. Happy?
Oh.
Semicolon.
Yes. I love semicolons. Semicolons are the best. Better than colons. I don't like colons.
Okay. Chris, what's the justification? That the big angle is made up of the 2 smallers added together. What theorem, postulate, or definition allows us to say that? That the big angle is made up of the 2 added together. Open up your book of truth. Start from postulate. No, your book of truth.
I don't have postulates.
Why not?
I don't know.
All right, they need to be in your book. We have 9 of them so far. And I mean book, I mean your book of truth. Okay? The Bible. Yeah, it's your geometry Bible this year. Absolutely. All right. Help them out, Micah. What postulate says that that's possible? That the big angle is made up of the 2 added together. Angle addition postulate. How many times have we said that so far? Well, any proof that involved angles so far, we've used that. And we won't see that the entire year, but absolutely. And for those of you that were sitting there that already knew that answer, good on you. For those of you who are sitting there like, I don't know, I'm just going to wait until he calls on me, and then I'm going to try to pay attention, and I'm going to be as clueless as everyone else. Right? Then you're not doing your job as a student. Okay. How many people right now know the next statement? Okay. That's what I would expect. However, when I write the statement, I expect more people to understand why I'm making the statement. Okay, so here's where we're at. I'm trying to get to here. What do you notice about both of these? What do you got? They both have an angle 2 in it, right? if I could somehow get an equality in there that used that angle 2, maybe I could do some subtraction, and I would wind up with 1 equals 3. Notice both of them have a 2. So it would be really, 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 really cool if I could somehow say that that equals that, because then I could subtract 2 from both sides and I would be done. The question is, can I say that this equals this? Clearly the answer is going to be yes, but the question is, how can I do that? Well, let's see. What is, maybe I need a new color. Here's the kicker. What does this say right here? What does it say? Now here's where you got to pay attention. Here comes the big kicker. What does it say? If I see AOC, what can I write? Well, I see AOC right here, so what can I write? Further, this says BOD is equal to this. So instead of writing BOD, I can write AOC, or vice versa. And further, double substitution. Further, are you with me?
We have to write doubles.
Do you understand that this says that they're equal?
Yes.
And that if I see the letters, angle, measure of angle BOD, I could write AOC.
Yeah.
What does it say right here?
The AOC.
No. What does it say right there? So I could write,
AOC.
but AOC is equal to 1 plus 2. So I'm not going to write AOC. I'm going to write 1 plus 2. I'm not going to write BOD. I'm going to write, all I'm doing is taking the blue statement and writing the green statement. It literally says these two are equal. Sure. Further, it says instead of writing AOC, I can write that. Are you with me? Instead of writing BOD, I can write that. Click. And that's what I'm going to do. That's the technique that you will see lots this year. This is a double substitution. This isn't really transitive. It doesn't say if this equals this and that equals that, then the two. This is more of a double substitution. If you're sitting there right now and you're like, I have no idea what just happened, that's bad. If you're sitting here, you're like, good Lord, how did he know to do that? That's okay, because that's what we will learn this year. But if you can't see that where this double substitution came from, this says that AOC is the same as BOD, and this says instead of writing AOC, I can write 1 plus 2. I did it. And this says instead of writing BOD, I can write, see what the equal sign is? 2 plus 3. You got the last step. How do I go from here to here? Say again? You got the last step. How did I go from here to here? What's missing from here to here? 2. So what? Guess what I did to both sides of the equation? I subtracted them. For those that can't see that, nice simple problem. 4 plus 2 equals 4 plus 2, right? If I subtract 2 from both sides, I get 4 equals 4. That's all I'm doing. Notice both sides of the equation have the measure of angle 2. You're like, wait a minute. How do you subtract an angle? It's not even in a number. Agreed. But this M doesn't mean an angle. It means the size of the angle. So really, this is a number. You could call it a variable, right? It's an angle variable. All right. So she correctly said that we use subtraction and we're done. So we'll take a step back, right? If you understood all the justification, eventually, you're good. If you're still worried about how am I ever going to come up with this stuff, don't panic yet. We'll talk about it in a month or so from now. Trust me, a month or so from now, most of you will be able to do this proof right here. Because this one's an easy. But it certainly isn't easy right now, right? Coming up with these statements. All right, we okay? All right. Let's see how many of these. By the way, remember you have to end a proof with either a square or QED. Did I put it? Wow, this entire year, no one last year caught me at all. I didn't even catch it. I'm tired. That's a lot of work. All right. Geometry is a different type of satisfaction. So we're just take a brief segue and just talk about substitution and transitive property. So if A equals B and B equals C, then that is the classic transitive property. We also can use substitution. Check this out. If A equals B, then anytime I see a B, I can write. And if B equals C, anytime I see a B, I can write. If B equals C, then anytime I see a B, I could also write. Oh, he's jumping ahead. C, right? So using a double substitution, I could also get to that. So the big question I have in geometry kids' mind is when they get to this thing, I'm not sure if I'm doing a transitive property or a substitution. Transitive property is just a double substitution. Okay? All I'm doing right here is instead of writing a B, right? Because it says B is equal to C, I'm writing a C. So I don't care if you write transitive or substitution, if that's the statement. Other times, like this one, hey, I got an equation, A equals B plus C. We're told that B equals D and C equals E, so I can rewrite this as A is equal to D plus E. That is not transitive, that is a substitution property. So I guess what I'm telling you is this. If you're in doubt whether you're doing a transitive or a substitution, guess what you should always write? They both can be called substitution. So if you're wondering, I'm not sure, am I doing transitive or is that substitution? Guess what you should write? Just write substitution. They're both substitution. When we actually do a real transitive one, I'll point out, hey, by the way, that's transitive right there. This was, for some kids, hard to, like, I don't know which one to write, substitution or transitive. Yeah.
Can I temporarily forget a transitive property?
You can, and be fine for the entire year.
Okay, thank you, please.
All right, let's see how many of these we can do. We're probably gonna get through one. All right, whole lot of stuff going on, right? How do we always start proofs? Right, there's my given. This is box 4. We're told that these two angles are the same and these two angles are the same. All right, I need to get the two measures are equal to each other. So I need to get some equation that talks about measures. We're going to do this the same way we've done the other ones. Matt, what can you tell me about this angle right here?
1 plus 2 is ABC.
What can you tell me about this angle right here?
4 plus 3 is equal to
Okay, and as soon as I do that, then at least I'm getting some numbers in there. So let's do that. So this one, after we've done the previous 3, maybe you could have gotten that statement yourself. I don't know, maybe this is a good place to start. A lot of times when you do a proof, you don't even know if you're going in the right direction. All right, Chris, you're on again. What allows me to say that the big angle is equal to the sum of the two smaller ones? Postulate 4, good job. Which is called the angle addition postulate. Now, if you can remember postulate 4, good on you. Too much from now, you're going to forget whether it's 2 or 4. 2 is the segment addition, 4 is the angle addition postulate. So I just write the words, and you'll see me do that throughout the year. Unless it's a theorem that doesn't have a name, then I have to say by theorem, blah, blah, blah. Okay? I'm trying to get to this. Well, what did I do? Tell me what to do.
So, yeah. The measurement saying 1 is equal to angle 3.
So if 1 equals 3, then anywhere, let's do colored pencils again. This says 1 equals 3. So anywhere I see a 1, I can write 3. This says 2 equals 4. So anywhere I see a 2, I can write a. Notice what DEF says. DEF is equal to 3 plus 4. If I could somehow turn this into 3 plus 4, these two would be equal. Can we do that?
Yeah.
Okay. Because of what I just underlined. This says anywhere you see a 1, you can write a. Anywhere you see a 2, you can write a. So I'm going to do that. It doesn't matter which one you choose, whether you choose this statement or this one. I forget. I'll probably choose ABC. Let's see what I showed. I did ABC. So I could have also said DEF is equal to 1 plus 2 by that same logic. So I said ABC is equal to 3. How am I able to say that? This doesn't say 3 plus 4. It says 1 plus 2. But the previous one said that if you see 1, you don't need to write 1. You can write a 3. So I did. And it says if you see a 2, you can write a 4. So instead of writing a 2, I wrote a 4. And that's the. All right, you tell me. Not this part. Are you lost on this part? Okay, now you tell me how many more people. Okay, I kind of saw what was about to happen right there. It's good, right? Okay, so why did I write that statement? Because what does this thing say right there? It says exactly the same. So I could write them that this actually equals this. And I will do that now. And by the way, that's how the proof ends. What allows me to do that? Okay, what did I do? Somebody said it. It is a substitution because all I'm doing is, instead of writing 3 plus 4, I'm going to substitute what it says right there. It says if you see 3 plus 4, you can write DEF. So instead of writing 3 plus 4, I wrote DEF. Which proof? Which property did I say we use almost every single one? It's like 99, 95%, somewhere up there. It's substitution. QED, we're done. And I think we're literally done right now because we get out of here right now. All right. I don't want this to always end on a I'm going to fail note. So I'm going to end this way I started this. If you're okay with this column right here, you're in a good spot. If you're still worried about this column, then you're still in a good spot. If you worry about how am I going to come up with those statements, you're in the wrong spot right now. Some of you might have been able to see how this is kind of flowing now. Right? But most of you are probably still, trying to wrap your head around this one. That's fine. All right, see you tomorrow. And by the way, try to get your proofs done in student advisement so I can give you some help. All right, e-learners, if you have any questions, send me an email. Yeah, and it's gonna get a whole lot easier.